Good morning to all for the second day sessions. Navinathan, please switch on your video, please. Navinathan. Are you able to hear, please? Are you able to hear? Chat it now. Okay. Okay, thank you all. And Navinathan? Navinathan, are you able to hear? Navinathan, are you able to hear? And switch on your video, please.
Yeah, sir. One second, sir. One second. I'm connecting my camera. Sir.
Hello.
Morning. I was not prepared for the video, that's why.
Yeah, no problem. Just for a few minutes, the video should be on when I am introducing you. After that, you can see the video. And you can check up whether you are able to see, share your screens and other things, please.
Yeah, I'll do it now, sir.
To check it up whether are you able to share the screen. Then you will start the program immediately.
Okay.
Yes.
It's clear, right?
Yes.
Okay, sir.
You can make it small so that we can start up the program. Dear participants of this second day session, where Navinathan will be taking up the task, where he will be talking about. One second, please. Where he will be talking about neural networks and the algorithms related to the machine learning and other things of today's event, where he will be conducting 3 sessions from the base. Sometimes some basic mathematics also you will be introducing it where it is being there. That is, the topics will be covered in this today's class will be basic steps for data science and machine learning, data manipulation, visualization, evaluation matrix, machine learning models of KNN, K nearest neighbor, selecting the right model, linear models, and small project demo. So these are all the topics in this session 1, session 2, session 3 of second day will be conducted by Navaneet Malinga. So there is a small introduction about Navaneet Malinga. He is the founder and CEO of Nuneri Labs Private Limited, Coimbatore, and he is a course instructor and content creator of our Femtech Poland, and he is a coordinator and speaker of TensorFlow user group of Coimbatore division. and he is heading a team as a Dean of Coimbatore Artificial Intelligence Group. And Nivu Academy is mentoring the students on online, providing them with STEM education. And he is an IoT developer at Wayway, Texas, USA. And he is being a software consultant for Yoni Technologies, Coimbatore. And he had a previous experience of working on research and development as a consultant in Krishish Technology, Coimbatore. These are overall the clans of which about Navinith Malinga. Apart from that, he has done his MS from research from GCT. Apart from that, he is being working on what we call it as an Udemy's content and other areas also. So we request Navinith Malinga to take up the sessions in such a way that the participants will be get benefited and it will be useful for them. So thank you.
Sure, sir.
So Navinith Malinga, now it's your time for it.
Okay. So thanks, Sridhar, for the wonderful introduction. And again, good morning and welcome everyone to the today's session. As Sir said, today's session will be about the entire data science life cycle, the machine learning pipeline. So right from the problem definition to the data collection and data cleaning, data pre-processing, feature engineering, then building models and how to evaluate models, and finally how you can deploy it. So it will have like a basic steps of everything. Okay. And also for some newcomers and beginners, I have certain prerequisites, certain basic general fundamentals about AI. Then we will slowly move on to the actual today's concept. Okay. um I'll just can I turn off my camera, right, sir?
Yeah, please. Yes, please. Yes, please.
Okay. Okay. So that I can have a different arrangement of mic so that it will be more clear. Fine. I'll put it into full screen. My screen should be visible, I think. Yes, sir?
Yes, it's visible, please.
Okay. So, yeah, a little bit of about me. Already Sridhar sir told a lot of things about me. I'm currently working as an AI and IoT researcher, developer, and educator. So I don't wanted to just narrow down my work into any one of these domain. I still wanted to be a researcher and an hardcore software engineer, and wanted to educate students as well. So currently I'm working on my pet startup, Nunary Labs, and again. That is what I do, and again I organize few communities, AI communities in Coimbatore. These days I'm fully involved in education, so that is also one of the reason I am associated with the Ramakrishna mission with Elia for their courses and other projects, and the ATAL FDP as well. So let's start with defining a simple question. Okay, so because this is just the second day of it, a lot of people would be a very beginner into the domain of AI and stuff. Okay, so let's ask a question like, what is AI? Okay, so in broad terms, basically what we are trying to do is we are trying to mimic some human intelligence. Okay, we are trying to put an human intelligence into a machine, right? So that's the primary goal. But what are all the traits, or what are all the characteristics of intelligence? We see that the humans, what we can do planning, we can do learning, reasoning, problem solving, knowledge, representation, perception, motion and manipulation, social intelligence, and creativity, and we can do a lot more, right? But modern AI tries to break down these things into an individual task and tries to address all these problems one at a time. Okay, so we will try to implement few things, maybe decision making, or else maybe planning, or else learning a function. So that is what we try to do in today's session. Okay, but social intelligence and creativity, it is now possible through AI, through advanced models like GANs and auto encoders and stuff, but that is for another day. But today we'll do the basic prediction stuff that humans are very good at. Okay, so if you compare the modern AI and what AI is capable right now, so humans, we have memory, we can learn and retain memory, retain concepts. We have perception, see and understand things, anticipation, expect something to happen. Okay, problem sol- problem solving and decision making. Okay, so given any scenario or situation, we can come up with a proper decision to tackle the situation, right? And on the other side, we have intelligent softwares that can do natural language processing, right? So that can understand human language and tries to interpret it. And next we have computer vision. If you see the modern computer vision algorithms like Inception or whatever it is, the neural network base, they actually outperform human vision system. And next we have dialogue on conversation, chatbots, and domain data, and machine learning, learning from data. So these are all the few things that AI have achieved in the last few years, right? And if you see the subsets of AI, that is more important. Okay, so AI is a very broad term. So AI is not something that new. You can see it actually started in 1950, but it dates back even earlier. But AI as a proper academic career kind of kickstarted in 1956 by John McCarthy and its colleagues at Dartmouth Conference. Okay, so AI, any technique that enables machine, okay, to mimic human intelligence. So that is what AI is. The ultimate objective of AI is that. Okay, it has a lot of things. It has mathematical models, probabilistic models, probability stats based models, decision trees, and expert systems, RPAs, a lot of things, right? So it is a very huge umbrella which accommodates everything. Okay, and the current trend is machine learning. Okay, because we cannot hard code the rules for every problem and every solution. That is not a way to go. But what machine learning tries to do is it tries to learn from data by itself. Okay, so all that the machine learning does is tries to find the pattern between the data and try to predict something or try to replicate it. So that is what machine learning does. So, and again, if you see the year, it is also not something that is new. It's from 1980s. We have seen naive Bayes and decision trees models back then, 40 years ago, being used in industries for decision making and other things. Okay, but the current trend is deep learning. Okay, so deep learning is kind of inspired from human brain, where it has neurons and synapses. Okay, and again, it can model much more complex functions. Okay, and it is very suitable for nonlinear problems, especially in image processing, image classification, and natural language processing. Okay, so that is fine. But if you see the definition of machine learning, okay, so it's a subfield of computer science that gives computers the capability to learn. Okay, so what is learning? We will see today. Okay, without being explicitly programmed. Okay, so this AI or machine learning kind of brought a trend recently called as software 2.0. Okay, in software 1.0, humans has to write all the rules and decision making. Okay, and we try to evolve it. But the software 2.0, it's much more easier. You just feed in the data. Okay, and all the rules are derived from the data itself, so that it kind of I feel more comfortable than writing machine learning code. I feel more comfortable writing machine learning code than writing the hard coded rules. That is pretty much very easy task. And if you see the categories, supervised, unsupervised, and reinforcement learning, okay, we will see them one by one. Okay, and supervised is further classified into classification and regression, and unsupervised learning into clustering and dimensionality reduction. Okay, so we have a lot more, but these are all the very top level and most uh, categorized things. Okay, so if you start with supervised learning, okay, simple. Supervised learning is always trying to teach a machine where you give both the input and output. Okay, so let's take, I'm teaching you mathematics. Okay, I teach you 1 plus 1 is equal to 2 and 2 plus 2 is equal to 4. What I do is I give you the question, which is 1 plus 1, and I give you the answer as well, the 2. Okay, and when I ask you some new question, what is 3 plus 3 or 5 plus 5, then you come up with the answer. Okay, if I don't give answer, but you have to find the answer from the previous example. Okay, so it is supervised. From the name itself we can understand. Okay, we feed in the machine with the questions and the answers. That is what we call it as inputs, and the corresponding output are called labels. Okay, let's see some examples. So let's say we have this pen, and we have a, we call it a pen. Okay, the image of the pen is there, and we call it as a pen is just a label. Okay, and here we have an image of pencil, we call it as a pencil. Okay, and next we have a highlighter, and we call it as a highlighter. So here the pen, pencil, and highlighter are called as the labels. Okay, but the actual image, the actual pixels are known as the input. Okay, so here this is input, and this is kind of the labels, right? And it's similar to training a kid. Okay, so in order to train a kid like a 3-year-old kid or 4-year-old kid, you show them these examples and tell him what is this. Okay, because he would be using, you'd be writing, practicing ABCD or 1 2 3, and suddenly if you ask him what is this, you would recognize it wrongly and tell it as a pen. because highlighter mostly a 3-year-old kid wouldn't use. Okay, maybe for sketching sometime, but only the adults or we use all these stuff, right? So he come up with a wrong prediction. But when you ask him what is this, it's a completely new image, but it is in similar shape and size. Okay, so he can easily able to predict this is a pen. Okay, so a supervised learning problem is you have both the input and the output. You train the machine as you train a person using the input and the output data. And when you come up with a new input data, you will try to find out the answer for that new input data based on the previous experience. So that is simple machine supervised learning. Okay, let's see another example. Okay, this example, let's say I give you 1, okay, and you got 1, and I give you input 2 and your output is 4. If I give input 3 and your output is 9, okay, and if I give input 4 and your output is 16, and what will be the answer for 5? Okay, so you would have recognized it is 25 because it's a quadratic equation. But the main thing is I didn't even tell you the formula of the input and the output. Okay, so the input to the output, the function is x square. So when you take an input number and you square it up, you get the output. But even before I tell you the formula, you yourself had found out the answer by analyzing the pattern of the data. Okay, so that is what supervised learning is problem. Okay, so we are trying to map a function, trying to like approximate a function for a given data pattern. Okay, but again, in supervised learning, the right answers are already given. The machine tries to learn from the data, and whenever a new data comes in, it tries to predict based on the previous experience. So as we have seen, supervised learning, it has two categories, always two categories. One is classification and then other is regression. Okay, classification is a pen or pencil problem, whatever. So it has a discrete set of classes where the output will be regression is a output. Okay, so if I want to tell you an example, so classification like will it rain tomorrow or not? Okay, then it is a classification problem, like yes or no. Okay, but what will be the temperature at 3 o'clock tomorrow? So then it is a continuous value. It's at some temperature number, right? 28 or 30. So that is a regression problem. So given the value of y, not a single y, you can pass in y1, y2, y3, whatever the features you have, and it will find a continuous valued output. And again, classification is all about mapping input to a small set of discrete values. Okay, and regression is mapping input to a real valued output. Okay, so I think I recite the concept what I teach again and again and again so that it will be solidified to you. But all these things are fundamentals. We will get into further more detailed concepts. So, but what are the applications of supervised learning? So what we use in our day-to-day life, a lot of things, n number of things. Every software component, what we use as a small touch of AI or ML within it, without even knowing that we have been using that, right from Google search predictions, okay, to Google photo tagging, Facebook photo tagging, product recommendation, Amazon, Netflix, and Flipkart, biology, medical test, DNA modeling, diagnosing, prediction, all sort of stuff, spam detection in our Gmail, and a lot more like in your keyboard, the word prediction, dictionary, face unlock. So the application is countless. Okay, so you have a lot of things in that. Okay, and let's come to unsupervised learning. Okay, so the today's topic will be implementation will be fully on supervised learning, but you should also know what unsupervised learning is. Okay, so in unsupervised learning, it's compared to be difficult because here you don't have the objective, don't have the objective in the sense you don't have an output. Okay, because here you only have an input data, but you don't have an associated output of it. Okay, so all you try to do is try to group them based on the similarities. Okay, that is what unsupervised learning mostly tries to do. But unsupervised learning has other application. It can do auto encoders, it can do GANs, it can generate new data, but the primary objective is clustering. Okay, based on the similarities. So let's take these images. Okay, so all these images are kind of different, but if you wanted to categorize them or group them, how you can group them? You can group them into class 1 and class 2 like this. Okay, but how did you do that? Because class 1 is most pipe shaped, it has a thin structure. Okay, it has sharp at one end because all these things are the similarities between the class 1, objects of class 1. Okay, and the class 2 is you have round shaped, you have broad structure, and you have smooth surface. So all these things are similar stuffs, and you classify them and as a class 2. Okay, so unsupervised learning can be used mostly for clustering and also for density estimation and dimensional reduction and for a lot of things, right? And third is reinforcement learning. Okay, so reinforcement learning is kind of quite exciting. Okay, but previously we have not seen a lot of practical applications, but recently reinforcement learning is penetrating into every domain. And again, it's most exciting as well because it is similar to how humans we learn. Okay, so here what does is a agent. Okay, agent like a human. Okay, and it has an environment. So for us, the environment is the world. What we do some actions and we learn from the experience, right? So similar to that, an agent will try to behave, do some action in an environment. Okay, and it would get positive and negative reward, so that it would try multiple times and tries to learn from the experience. Okay, it's similar to supervised learning, but supervised is more or mostly about input and output, but reinforcement learning is mostly about outcomes. Okay, so what goals you have and what actions you have to take to achieve that. Okay, it's similar to training your dog or whatever it is. If your dog behaves well, then you know this is the right thing to do. Okay, but if it misbehaves, then you put him down. In that case, it will know, okay, I shouldn't repeat it further. So we have a policy based network where you can have this positive and negative reward thing and do your modeling. Okay, and it's been used in a lot of places. Okay, especially right from landing a drone, self-driving cars, playing games, playing board games, playing computer games, and a lot more. Okay, and again the breakthroughs in reinforcement learning in 2015, actually happened in 2015, late in 2017. The AlphaGo Go playing bot created by DeepMind, which is a part of Google. Okay, that it actually beat the world's grandmaster, like greatest player KG on the Go game. But people had never thought this is possible. People expected this to happen maybe 10 years down the line. Okay, maybe in 2030, but it happened much more earlier due to a lot of reasons. Okay, but we will see what those reasons are. Okay, so as I said, we are seeing a rapid progress in machine learning in the last 5 years. Okay, but as I said, it dates back to 1950, but rapid progress in last 5 years. Everyone from every domain, right from medical, life science, history, agriculture, engineering, computer science, ECE, everyone are trying to get into AI. Why? Reason is because it is not uh, restricted to any domain. Okay, it's not just computer science, it can be applied to anything in the world and can improve the result, right? But why machine learning right now? So there are a lot of reasons for machine learning happening right now. Okay, the first and foremost reason is data, the availability of the data. Okay, so without having data, you cannot train a model, right? So in order to let's take a 3-year-old kid or 5-year-old kid. So as soon as it born, if you put him in a closed room, then what will happen? Suddenly after 3 or 5 years, if it comes out, it wouldn't recognize what is a human is, what is an animal is, and it wouldn't have learned a language because uh, a child continuously fed with data through his eyes, through his ears. It keeps on hearing. Okay, it keeps on seeing things, and parents teach them what is this and what is that. Okay, so similar to that, we need enormous amount of data. So back then it is not possible because we didn't have enough storage capability. So right now only the 10 GB data pack, or else having an SSD, having an flash drive of 1 TB is possible, right? But 10 years ago that is not even possible. We just have a that memory is very expensive. So now we have enough data. Okay, so what is the second reason for AI happening right now is the availability of the ML hardware. Okay, so once you have all those data, you need powerful machine to crunch all those data. Okay, so right now there are multi-core processors available, GPUs available from Nvidia and other manufacturers. We have TPUs, custom hardware for machine learning and deep learning. Okay, and if you see, now we have a smartphone. Okay, let's take a smartphone. The modern smartphone has kind of 16 GBs of RAM, 2 TBs of memory, and octa-core processor running at higher clock speed, and it is, and within a size of our palm, it is far more superior than the supercomputer 20 or 30 years ago, right? So now we have a supercomputer within a palm of our hand. So that is the second reason for the AI acceleration right now. Okay. And the third reason is the availability of the open source software. Okay. So if at all for not like if the Python is made as a premium tool, all these scikit-learn, pandas, numpy, whatever the machine learning tools, if all these things had made a proprietary tool, and if you wanted to pay a monthly subscription, technology will not accelerate in this speed. Okay. So just because all these things are made open source, a lot of people can use it without any cost from anywhere from the world, and also they can contribute back to it. Okay. So and again, it grows rapidly. So that's the third reason for AI right now. You can see TensorFlow from Google, PyTorch from Facebook, Café, a lot of libraries from different universities. Everything is made open source so that anyone can build solution using them. Okay. And the fourth reason is the availability of the smartly crafted algorithm, right? So if you see, if we leave the machine learning researchers, okay, they come up with new novel techniques, and they come up with new innovative ideas to different architecture, different mathematical models. But rest of the stuff, we just use the existing model, right? We don't try to create new model. We just choose the right model for the right problem, or for the right data. Okay. So that is what here we try to do. Okay. So all these algorithms, right from classical learning algorithms, we have classification like naive Bayes, linear regression, logistic regression, k-means, a priori, t-SNE, pca. So all these things are classical algorithms for classification, regression, dimensional reduction. And we have neural nets and deep learning, especially CNN for image, RNN for sequence, GANs to generate new things, autoencoders to noise reduction and to map functions, multi-layer perceptrons. And on the third side, we have reinforcement learning algorithms, Q-learning and deep Q networks, and ensemble methods, stacking up multiple models to improve the accuracy. So we have all these algorithms. Like these are the most top 30 or 40 algorithm that being used in the industry. Okay. So if you know all these things, then you can consider yourself as a machine learning pro, so that you can use this model anytime based upon the data. Okay. Fine. But when and where to use this algorithm? Okay. So first thing, so even though all these things exist, okay, so why AI right now? We have enough data, we have enough compute power, we have open source tools and softwares to deal with them, and we have all these algorithms already designed. Okay. We can just take them, put them together, and can build wonderful solutions. Okay. But way to use the right algorithm, there are different types of algorithm, we will come to them in detail. Okay. But let's ask a question like, is this A or B, right? If you wanted to find yes or no, pass or fail, cancerous or cancer no, okay, in that case you can go for classification algorithm. Okay. If you want to find, is this weird, is there any weird pattern is being followed, then you can go for anomaly detection algorithm. Okay. And how much or how many, then it is a regression algorithm. And how this is organized, then it is a clustering algorithm. Okay. And what should I do next is a reinforcement learning algorithm. So these are all the top five categories. Okay. And in every of these classes of algorithm, we have 5 to 10 algorithms. Okay. That we can use based on the need and based on the data. Okay. And if you see the if you see the KD Nuggets poll, top data science and machine learning methods, so we have regression. Even though it is very simple, it's been used in most of the places. We have decision trees, we have clustering techniques, visualization, random forest, statistics and descriptive methods, K nearest neighbors, time series, ensemble methods, and PCAs, and a lot of stuff, and neural network support vector machines. So again, these are all the top most used algorithms currently in research and in practice. Okay. But what is data science? Okay. So before that, I forgot to tell how this one day will be structured. Okay. Since we have got a lot of people in the line in the class, the first 1.5 hours of the today session till 11 o'clock, it will be mostly about the theory and also the intuition behind the what we'll be doing. Okay. Mostly we will deal with only the slides. Okay. So we have about 100 slides. We will see what are all the things. I'll try to pour in as much as knowledge I can, or else as much as the thing on concept I can explain it to you. Okay. And for the second session, we will get into the code. and we will go through the entire machine learning pipeline, and we will see what are all the steps involved in there. Okay, and we will learn techniques and tools and the process one by one. We have 5 to 10 processes. We will learn every single process separately. And finally, in the afternoon session, we will take up a project. Maybe we will take up a data set from UCA repository or a Kaggle repository, and we will try to solve the problem based on the learnings what we have done in the session 2. Okay, so that's what we will try to do. Okay, fine. So let's again get back to the slide. Okay, I think you got a pretty much intro to AI domain. Okay, AI landscape. We have regression classification algorithms. Why AI right now? We have all sort of things, and you know the reason. You know the algorithms. And let's get to what is data science. Okay, so data science. It is if you see as a domain, it's a multidisciplinary field. It is a merger of computer science, mathematics, and the domain knowledge. Okay, so computer science, why you need computer science? In order to implement. Okay, so anyway you have to write code only that can work. Okay, that can actually work, because model mathematical formula cannot work. Okay, so first thing, you have mathematics and statistics. That is where you model things. Okay, so machine learning is equal to mathematics. Okay, it's not machine learning equal to software engineering. Machine learning is equal to mathematics plus software engineering. Okay, so all your problems, your data problems, prediction, classification, everything is some mathematical formulas. Okay, you can take all those mathematical formulas and you can efficiently implement them in computer science. Okay, you can write programs and you can implement them. Okay, but and the third thing, the most important thing, is domain and business knowledge. Okay, so without business knowledge, just with maths and computer science, you cannot do anything. You can build new algorithms, but you cannot actually solve problem. Okay, so let's say you wanted to stock market prediction. Okay, for that you need a stock market expert. Only then you can replicate his brain. Okay, his brain is stock market knowledge into a computer machine or a computer model, AI model. Okay, and if you wanted to do some medical image classification, then you need to collect the data, and also you should consult a doctor. Okay, so only then you can able to replicate his way of diagnosing or identifying something into an AI model. So domain and business knowledge is very much important. Okay, in order to do data science. Okay, so you can see the merger when math and computer science joins, it's ML. When computer science and domain knowledge joins, it's software developments for automation stuffs. And when math and domain knowledge joins, it's traditional research or something statistics related stuffs. Okay, and what is the end goal of any data science project? Okay, so we should have an end goal, right? So a data product can be anything like a dashboard. Okay, you can do something and present it in a beautiful manner so that an business owner can understand what is happening. Okay, and the second is a recommendation engine. You can do some prediction classification and you can give some service so that people will get benefited out of it. Okay, and third is decision making to solve business or any problem. Look, this will be the most of the time these three will be the end goal of any data science project. Okay, and a data product should answer should help answer a business question. Okay, so without business there is no data. Okay, there is no data science itself. Okay, why I'm telling is, while learning, mostly people go in approach like first they learn the algorithms. Okay, then they take the data and do something with that. Okay, but when you get into industry, it always starts with a business problem. Okay, why this is happening, or else how this is happening. Okay, so from the data question, then we go and collect the data, or else build a system which can collect data. Then we store data in an efficient manner. Then we build system, well build models, we train them, and we come up with a system. Okay, so it's always about business. And we have a lot of applications. If you see travel, dynamic pricing and predicting flight delays. If you see marketing, uh, customer target or customer targeted ads, upselling, cross selling, predicting lifetime of a valuable customer. And if you see healthcare, disease prediction and medication effectiveness, social media, sentiment analysis and digital marketing. Okay, sales, again discount of offering and demand forecast. And automation, self-driving cars and pilotless aircrafts, drones, everything is automated. Industry automated everything. Okay, automation is different, autonomous is different. Okay, so automation is it's mostly some rule. The system behaves based on the rule. Autonomous is it is able to adapt it. Okay, so the next thing to automation is autonomous, right? and we have in credit and insurance, fraud detection and crime detection. So we have a lot of applications, a lot of business applications. Okay, but let's see a life cycle of data science project. So that is where we are actually getting into the session for today. Okay, so what are all the components and what are all the things for a data science project? Okay, so people think modeling. Okay, if I import scikit-learn dot linear regression dot fit dot predict, then it is done. Okay, but that is not the case. What happens in a real time? Okay, so it is a series of steps, very time consuming, critical steps. Okay, if you tell like the machine learning part is actually the last 20%. Okay, the 80% of the time, the first 80% of the time, it has a lot of things. You will see them one by one. Okay, and also if you compare it with the software development life cycle, okay, that is much more easy, since if you are from computer science background, you can easily relate things. Okay, so if you want to build a software or a tool, first thing what you do, you uh, collect the requirements. Okay, and you do a system design, architectural design. Okay, and do some implementation. Yeah, I think it's clear right now, I think. Yes, yes, my voice is audible, right?
Yes, sir.
Okay, I think it's audible. I turned on my mic. Sorry for the glitch. Okay, so if you take the software development,
Navneet, sir, it's not audible. Sir.
hello, am I audible?
Yes, yes, Navneet. Again, it's
Okay, yeah, okay, so fine. So, yeah, fine. So if you see a data science project, the data science project will look similar like a software engineering project, but it will lead to these things. Like in data science project, you might encounter delivery delays, okay, repeated hub holes, non-linear cycles, highly iterative and cyclical between teams. Okay, so we will see all these things one by one. Why this happens in a sense, because a data science project, you cannot define a particular route or a particular set of tasks, because only when you get into the problem, or else when you start analyzing the data, you will know which direction to go. Okay, or else sometime you will be taking in a direction and you will meet up in a dead end, you cannot continue it further. Okay, that will occur most of the times. Okay, and it's not a uh, very static workflow. Okay, so that's why it would be lead to a different lot of delivery delays. Okay, repeated hub holes. Why repeated hub holes? In the sense, sometime you would be doing the modeling, then you will be needing a set of data, but those data is not available. Then what to do, you go and collect the data and come back. And again, if you put the model to training, okay, so in software development, you do everything, compile and see the result, then it is done. But in machine learning is not the case. Let's say you have collected 1,000 images, then you train the model. If you have supercomputer, then it is fine. High performance computer, then it
sir. Again,
transform the data.
Navneet, sir, again, it's audio breaking.
uh, is it okay now?
Yes, yes, Navneet. Navneet, on participant asked about that we missed the previous slide like that. He told no. Well,
Okay, once again, yeah, previous slide should be this, I think. Okay, so the data set. Okay, I'll give a quick recap. Okay, it's a data science life cycle. It's much more complex than we know. Okay, When you compare it to the software development life cycle will go like this. You gather the requirement, what you need in the software, okay, from the client. You do the system design, architectural design, choice of language and frameworks and stacks and servers, okay. And third, you implement it and test it, okay, test it and deploy it, and finally it goes to the maintenance phase. Okay? This is how a software development life cycle will look like. But if you take a data science project, it is not, it will look similar to a data science a software engineering life cycle, but it is not same, because data science projects are highly iterative, okay, because you would be, you don't know what will be the end goal or what will be the end result. You know the goal, but you don't know the result, okay. So you will be trying multiple things. You cannot have a fixed time schedule for it, or else you cannot uh, define or give a solid deadline when I'm going to complete it. Okay, so that's why you would be leading to delivery delays, repeated hurdles, non-linear life cycle, and it's highly iterative process and cyclical between teams. Okay, and as I said, we have seen all these things. Data science is uh, like you need to do a lot of data crunching before getting into the data machine learning modeling. Okay, and if you see data science, it is more of science and less of engineering. Okay, so if you wanted to software engineering, then your choice of tools will be Java, C++, and JavaScript. Okay, but data science, where you go for mostly Python and R, and it is mostly modeling and prototyping. Okay, uh, most 90% of the data science project, it is not production ready. Okay, so all we are trying to do is come up with some results, come up with some prototype or a proof of concept, so that something is viable, okay, something is implementable, then we can do the software engineering on top of it. Okay, and coming to the data science life cycle, as we have seen in software engineering, we have certain techniques like Scrum, Agile. We'll put up some sprint. Okay, so it has a process, right? But for data science, we don't have a solid process. But this is one framework which most of the things would follow. A lot of people don't know this even exists, but this is a general framework for data science project. Okay, so the first thing is business issue understanding. So, okay, you should understand the business, what we're trying to do and what we're trying to implement. Okay, and the second thing is data understanding. Okay, so now you know you have the business end goal. Now you need to do the data analysis. Exploratory data analysis is the key component of a machine learning data science life cycle. Okay, you need to do data exploratory data analysis. It involves data transformation, feature engineering, visualization, statistical analysis. Okay, so you do all the things in order to understand the data better. Okay, and third, you do data preparation. So that is where the feature transformation and feature engineering comes in. Okay, and finally you build model and analyze them. Okay, tune them, and finally you validate them, and finally it goes into a production system. Okay, it might be a visualization or it might be a model. So this is how things. So we will see all these things one by one. Okay, so you can see DM, it's been used in most of the project. 43% of the project use it, but even though 43 is not a big number, but half of the project you follow this principle. Okay, and again, if you see the data science process, first thing is ask a question. Okay, you don't go from data to model. You ask from that, you ask a question, then you collect the relevant data. So asking a question might be, what is the goal? Okay, and what you have to do with the data, or else what you want to predict or estimate. So that will be the question. And second is gather the data based on the requirement. Okay, so how the data are sampled, what data are relevant, are there any privacy issues. So these are all the concerns while collecting the data. Okay, so if the data is sensitive enough to uh, it is biased, gender biased or sensitive information, so we will be considering all those stuffs during the data collection. And third is explore the data, exploratory data analysis. Okay, so you have to plot the data, find the anomalies, find the missing values, remove them, clean them, transform them. I'll just giving you the hint. We will see every step in detail. Okay, so that is where the part 2 comes in. We will implement all these stuffs. Okay, and fourth is build a model, fit a model, validate a model, so that it can give a good accuracy. Okay, finally, communicate or visualize the result. Okay, you will be doing the result, and you can see after reaching here, and it again goes to the ask an interesting question, because within a single flow you cannot come to a conclusion. You would be iterating the steps, so you can come here and go back. You can, in from every step you can jump back and forth, okay, so that you would be able to come up with a good model at the end of the stuff, okay. And if you see the detailed data science life cycle, okay, we have uh, business understanding, and after that we can go to data acquisition. So data acquisition, understanding, it has two methods. So it involves, first thing is data source, okay. A data source can be on premise or on premise versus cloud, or database versus files, okay. So that is the data collection part. It can be anything in these categories. Second thing is pipeline, okay, how the data is coming. Either it is a batch processing. Batch processing is you collect the data and you later do the processing on it, okay. But streaming is as the data comes in, you do the processing of stream data, okay. And if the velocity is the data frequency is low or high, okay, that's the data pipeline. And third, environment, either you are doing on premise or cloud, database or data lake, and finally wrangling, exploration and cleaning. Okay, so in data pre-processing, we call it as wrangling, cleaning, munging, a lot of tasks, but everything is almost similar. Okay, so structured or unstructured data, data cleanup and all. So this is where the data acquisition and data cleaning part happens. So once it is done, you can directly jump onto the modeling part. Okay, in modeling also, it's not just building the model. First thing is you have to engineer the feature, okay, encode the feature or transform the feature. If you have a text, let's say how are you, okay, it is just a text. So your machine learning NLP model or classification model will not take in these text, right? So you have to convert these text into numbers. As I said, machine learning is a mathematical formula. To put simple, it is actually a mathematical formula only. So a mathematical formula, what it can take as an input, it can take only numbers, right? So that is where the feature engineering comes in. You can do transform, binning, text to integer conversion, encoding, one not encoding, integer encoding. We have a lot of stuff in that. Image, even in image also, you can do a lot of transformation. You can convert color to grayscale to something else, okay. And the second step is modeling, okay. Modeling is where you go for the right choice of algorithms and parameter tuning, retraining and model management, all these stuff. And finally evaluate the model. So we have certain evaluation metrics for classification or regression, we will see them, okay. And finally we also do cross validation and other stuffs to find the right model and to evaluate the model, okay. And finally it goes to the deployment phase. In deployment phase, only after deployment phase also has a lot of things. It has model versioning, different versions of models, services. It has to do load balance, because if thousands of customers are going to use your model, then it has to capable to handle that many incoming ingress and egress request, okay. Then your model has to be high performance. It is able to predict fraction of seconds so that it can serve. Your server can handle 10,000 requests, but your model should be capable of doing that processing or predicting that something, that, right? So every component has separate domain or a branch of its own. And again, for every stages we have different job roles and set of tools and techniques. And in top MNCs, people are at least 10 to 12 categories of people work on the entire data science lifecycle, okay, fine. And also there is enhanced CRISP DM, kind of similar: data acquisition, data preparation, hypothesis modeling, evaluation, interpretation, deployment and operations, fine. That's pretty much same, okay. So if you see data acquisition, so how to acquire data, because only an expert, only a domain expert will know what data to acquire, okay. So find a data expert, find what data to acquire, find when to acquire, and find how to acquire. So that is where the data acquisition part comes in, okay. And data science projects, identifying the data, okay. Now we have identified how to acquire and what to acquire. And the types will be like this, okay: logs from web servers, social media data, and online repositories like census data and other stuff, and data from different APIs, okay, REST APIs and other APIs, and web scraping. We can do all sort of stuff to collect the data, right? And it can be an Excel sheet, it can be an text data, it can be an HTML data, it can be a database, it can be a JSON or some API data from API. It can be of any form. And you can see how these things are handled, okay. And also there are different types of data. You have video data from YouTube, you have image data from social media, and you have blogs, text and sensor data from a lot of machineries and social media data. And these are all the data streaming platform like Spark, HDFS, how to store data, and Hive to do some analysis and run queries, and finally do for modeling. And again, if you see this data, once you collect the data, the second is data preparation. So this data preparation task is the most time consuming and also the important and critical task of machine learning pipeline. Okay. You can see often referred as a data cleaning. Okay. And the most boring and time consuming task. Okay. Because when you deal with, see, if you have done machine learning earlier, mostly what are done with MNIST data set, iris data set, or else a Titanic data set, even not even Titanic data set, iris data set, or some general data set. Okay. So all these things are pre-processed data set. Okay. So your data is clean. You just have to import the data and do the modeling. But when you go for real life, a lot of data will be missed. Okay, there will be a lot of missing data, a lot of non-linear data, a lot of class imbalance are there. So all these things kind of handled by this data preparation method. And as I said, it's mostly unstructured data. You have to reformat it for your use. And these are the data cleaning checklist. Okay, so how to clean your data? As I said, it can be missed value. Let's say you are conducting a survey, or else let's take census data. Not every column is filled, right? So they go to house, they take some numbers. Okay, if something is not there, then just leave it blank. Okay, and if you're trying to model the data with some machine learning technique, then there your model will be affected by the data. Okay, though your model is actually the data, it's not the algorithm. Okay, your model is actually the pattern in the data being captured by the algorithm. So data has to be very clean. Okay, so for that we have a data cleaning checklist. First thing, we need up-to-date data. Okay, so second thing is handle missing values. If any of the cells or rows or columns is missed, then we will be remove or try to impute the values. And duplicates will highly affect our model. We need to remove the duplicates. Numerical outliers, if there is any outliers, it might affect the thing. Like someone, let's say someone's date of birth is 2030. Okay, the in the census record, it is not a reasonable data, right? It's a pure outlier. Okay, because people can have like 2020, can have today, that is also okay, but you cannot get a census of newborn baby, but that's fine. But if you get 2030, then there will be a lot of outliers, so you need to remove that and check the IDs and data, valid data. So these are some of the data cleaning checklists. And we have different types of data: CSV, Excel, and JSON. Okay. And the second thing will be EDA, exploratory data analysis. You will be taking a small, you will be doing some statistical analysis on the data to understand and find the data. Okay, we will come to EDA later. Okay. But before that, why do we need to do the feature engineering? So as I said, uh, all the text and all the numbers you need to convert, all the data you need to convert into numbers. Okay, so only then the machine learning model would be able to uh, uh, take as an input and find the pattern. Okay, so you can see the right features can be only defined in the context of both the model and the data. Okay, so what features to use, transform them. Okay, so it is difficult to generalize the practice of feature engineering. It is not same for all the project. It's purely the feature engineering conclusions is made from the EDA. You do the exploratory data analysis and you find what to do with feature engineering. Okay, fine. And next is hypothesis modeling, and this is where the actual modeling comes in. So far what we have seen all about the life cycle. Okay, the data science life cycle. The first and foremost thing is business identification, business problem definition. And the second thing is data collection and data cleaning. Okay, that is what we have seen that. Now let's come to model building. So this is where you build models. You can build using Python, R, MATLAB, and Perl. So different languages. Okay, and these are all the set of algorithms available. Okay, regression, linear and decision trees, random forest, and for classification we have knn trees and loss regression. Okay, and clustering, singular value decomposition, PCA, k-means, and all, and reinforcement learning. So we will see this set of algorithms for today. We will implement all of these algorithms quickly. Okay, so you might wonder how you can implement all of these. We will not get into nitty-gritty details of how every model works, but we will write a loop where every model will get evaluated, executed, and will give us the result. That's super cool, right? Okay, we'll do that. Okay, and once you build your model, next comes the evaluation metric. So business is defined, data is collected, data cleaning is done, model is built. Now we need to find whether our model is good or bad, or how it is performing. Okay, so since we have restricted ourselves to a supervised problem. Okay, mostly it has regression and classification. Okay, so for classification is like yes or no problem, or 0 or 1 problem, true or false problem. There we have certain metrics. Mostly we start with confusion matrix, then we create sensitivity and specificity, then we calculate accuracy, precision, recall, F1 score, ROC, and EOC. We will see all these formulas one by one. Okay. Next is regression. Regression matrix is mean square error or mean absolute error. Okay. So regression is mostly used for continuous variable. Okay. So so accuracy is a classification I'm telling. So my answer has to be yes, but if I'm getting no from the model, then you need to find, you can compare them and you can find the accuracy. Okay. How much percentage is true to true and how much percentage is true to false, how much percentage of false is true and how much of false is false. Okay. That is where the confusion matrix comes in. We will come there. Okay. And regression is mostly about, I wanted my temperature, like the actual value is 33, but I'm getting in 32. Okay, so what is the difference between the actual value and the predicted value? That is where the mean square error comes in. Okay, so first thing we will see about regression. That's pretty simple. Mean square error. Okay, the difference between the actual value and the predicted value. I need to get 33, but I got only 32. So 33 is the actual value and the predicted value is 32. You subtract it. Okay, you subtract it, you get if you do 32 minus 33, then you get -1. If you do 33 minus 32, then you get +1. So that what you do is, to get a absolute value or to get a non-negative value, we just square it, or else we just do the absolute modulo. Okay, so that is where we can get the cumulative error report. Okay, so you subtract it, square it, so that the negative values will get cancelled, then you add it up. Okay, so that is what the mean square error is. Okay, and also we have different variants of it: root mean square, mean absolute error, almost pretty much similar. It gives the difference between the actual and the predicted value. Let's say this example, stock price prediction. So this green line and red line, okay, you can see a lot of correlation between them, but this blue line and red line, there is a lot of off between them. Okay, so here the red line is, there is more deviation, but this green line is okay, it's on top of it. And that way you can find the deviation you can find with these error or root mean square error. But let's come to confusion matrix. Okay, so confusion matrix, special type of matrix. We'll skip this, is not that beautiful. Let's come to here. Let's say your problem is trying to classify between pregnant or no pregnant. Okay, so based on the picture of the belly. Okay, that's a cool problem. And finally, if you see, if you have a flat stomach, then it is not pregnant. Okay, so first thing, if you have a stomach, mostly it can be a true positive. So you are pregnant and you have a belly. Okay, so that way you can go for true positive. And sometimes what will happen, this is not pregnant. Okay, so this is true negative, because she is not pregnant, and that is true. But in this case it is false positive. So she doesn't she is not pregnant, but she's fat. So based on the belly size, they have classified her as a pregnant. Okay, that's a false positive. Okay, and she is pregnant, but they thought she is obese or she is fat, and they have considered as a not pregnant. Okay, so these are the four things that can happen. Like when you have a yes or no problem, either you can classify yes as yes or no as no, or else yes as no or no as yes. There are four possibilities. Okay, so how you can present all these four possibilities through this confusion matrix. So this confusion matrix is for classification. It's pretty early to introduce all these concepts, but that is fine. We need to know how to evaluate a model, right? Okay. Sorry. So this confusion matrix will have true labels and the predicted labels. Okay, so this horizontal line is true label, and the top label vertical line is the predicted label. Okay, so when true and predicted goes in correctly, okay, negative and negative gets correctly, then you get value here. Okay, and positive and positive, you get value here, because you can see it both gets merged in this quadrant. Okay, but if you get positive as negative, then it comes here. So she is positive, she is pregnant, but you have classified as not pregnant, so that is this category. And negative, she is not pregnant, but she have classified as a positive, then it is a false positive, then this goes to this quadrant. So let's take a simple number. So we have like 100 people. In 100 people, we have 140 pregnant women, and remaining 60 are not pregnant. Okay, and you are trying to classify it. Okay, and your confusion matrix comes like this. Okay, first is negative, negative. Okay, out of 60 people who are not pregnant, 55 you have correctly classified. So no pregnant and you have classified as false. That is true negative. So out of 60, 55 is you have correctly classified. But 5 is you have classified as pregnant. So 5 non-pregnant women you have classified as pregnant. Okay, so it goes like this. Okay, so when you add them together, we get 60. And similarly here, out of 40 actual pregnant, okay, positive, positive, only 30 you have correctly classified. Okay, and 10 you have wrongly classified. That goes like here. So this is true positive and true negative. This is false positive and false negative. Sometimes this true label will come here, this predictor label will come here, positive and negative will switch places. But how you can find a how you can evaluate based on confusion matrices, your diagonal has to have the maximum values. Okay, so let's say if this is 0 and this is 0, in this case here we would have 60, here we would have 40. Okay, so that is what happens when you have all true for positive and all true for negative. Okay, so your diagonal should have the maximum values, but if it is not, then this value should be minimum. Okay, so based on these things, we can find the accuracy, precision, recall, and also that we will see. Okay, the first thing is accuracy. So what accuracy tells us is, so how much like let's say how much of true is actually classified as true. Okay, so it only cares about the true only. Okay, so out of how much of true positive and true negative has been correctly classified. Okay, so here for our problem we have 55 true negative and 30 true positive. Okay, and 55 plus 30 we do it. Okay, okay, and for rest of the stuffs, okay, rest of the stuffs is true negative plus false positive plus true positive plus false negative. So here it is 55 plus 5 plus 30 plus 10. So if everything is classified correctly, this number would be 0. So in that case, 60 plus 40 by 60 plus 40 will get 1, accuracy 1. But here we have like 5 and 10 misclassified. Okay, in that case we are getting 85% as accuracy. Okay, so that is what an accuracy is used to convey, right? But accuracy alone is enough. Okay, okay, now we got accuracy, we can easily find how much percentage the model is performing. Is that enough? But not enough, because if you use only accuracy, but let's say you have 90 people who are healthy. Okay, who are healthy is they get negative, and 10 people who have some diseases positive. Okay, in that case if you go for an classification like this, in that case what would happen is you get true negative. Okay, all the category, either they are pregnant or not pregnant, they are classified as positive. Okay, this is the true label. Okay, and in that case what will happen is everything would be like all the patients are classified as negative. Okay, so even though they are pregnant, it is classified as it is not classified as pregnant. And even though they are positive, and again it is not classified as pregnant. Okay, so whatever the data you give, it either it classified as not pregnant. Okay, in that case also you see the accuracy, it gives 90%. But here if you see, it's always predicts no thing. Okay, predicted always predicts no pregnant, then also it gives 90% accuracy. So accuracy metric alone will not be sufficient to evaluate a model. Okay, because if your data is like that, then you might get all negative or all positive, but since it would give 70 or 80% of accuracy, but that is not actually the proper evaluation metric. In that case what you can do is you can go for precision. Okay, so how precise the value is, like how many true is actually true, how many false is actually false. Okay, so precision has to be generally 1 high. Okay, so true positive by true positive plus false positive. So in our case we have true positive is 30, but false positive is we have 30 plus 5, like we have some false positive value as well. Okay, in that case we get 0.85. Okay, so if all true is all true, then we would get 1, but since we have misclassification, we can get some number. So in that case we can use precision as an evaluation matrix to find the aspect. But here you can see accuracy for overall model. Okay, and precision is for this, and recall is also kind of similar. Okay, this would tell us for a true negative value. Okay, But if you wanted to merge both the precision recall together, then you go for F1 score. Okay, this F1 score kind of uses both the precision recall in a single formula. Okay, and again F1 score has to be high. Okay, you can see it is precision into recall by precision plus recall. So if you, as our thumb rule, we need both precision and recall as one. Okay, so let's consider precision as one and recall as one. Then 1 into 1 is 1, but bottom you will have 1 plus 1 is 2. Then 2 gets cancelled, then you will get F1 score of 1. Okay, so mostly the final metric for a classification task is F1 score. Your F1 score has to be maximum, it has to be close to 1, or else if any of these precision and recall gets missed, gets zero point 0.8 or something, this formula will give a lower value for lower F1 score. Okay, so based on that we can evaluate the model. Okay, and also we would use AOC curve and ROC curve. AOC and ROC will stands for ROC stands for region operating characteristic and AOC stands for area under curve. Again, it's a lot of math, but we will see code. Okay, so once we see the code, all these metrics will get solidified. Okay, so I'm just putting these words into your mind so that later down the line when we see all these concepts, you shouldn't be confused. Okay, so evaluation metrics for regression is always this error. Okay, the true value and the difference between the true value and the predicted value. But for classification it's kind of different. So because we have different combinations, true true true, true false, false true, and false false. Okay, so then we can come up with this complex structure called confusion matrix. Our diagonal value has to be maximum, but this you can visually see and evaluate things. But if you want to find the numbers for accuracy and precision, then you go for these formula. So this true positive, true negative, you take all these values and substitute in this accuracy, precision and recall formula, so that you will get some number. Okay, so that number has to be maximum close to 1. Okay, so even if you don't know these formulas, leave it, don't worry. All these things, accuracy, precision, recall, and F1 score has to be maximum, should be close to 1. If you're not getting that, then your model is performing poor. Why do we need an ROC and AOC curve? Okay, ROC is, as I said, region operating characteristic. It is used to set a threshold. Okay, set a threshold in the sense, when you have a classification problem, it doesn't give 0 or 1. Okay, what it actually gives is, it gives a probability. So 0.8 percentage it can be of class 1, 0.02 percentage of 0.2 percentage it can be of class 2. Okay, so I'm telling, like, if I see a figure, if I see a fruit, okay, 80% it can be an apple and 20% it can be a pomegranate. Okay, so because both things look similar, both are red in color. Okay, so based on the probability we set a threshold. Okay, if the threshold crosses 0.5, then we make it 1. If it is below 0.5, we make it 0. So if it is 80%, then it is 0.8. It is above 0.5, right? In that case, we can label it as a class 1. This is apple. So if it is 0.3, then it is below 0.5, then we can classify it as a pomegranate. Okay, but this 0.5 is not an optimal value. Based on the data, this threshold also will move up and down. Okay, sometimes you can set the threshold to 0.7 or 0.8, even 0.9 based upon the need, and also you can reduce down to 0.3 or 0.4 based on the optimal threshold. You go for a metric called region operating characteristics, ROC. In ROC, what you do is, you set first, initially you set threshold is equal to 0.1, then 0.2, then 0.3, 4, 5, 6, till, if it is 0, then it is 0, if it is 1, then it is 1. But in the intermediate, we have the different sets like 0.1 to 0.9. So for all the different threshold values, you do your classification and you find the prediction whether it is yes or no. And based on that, you get a plot like this. Okay, so in that case, if you see, if the true negative, okay, and true positive doesn't overlap, so doesn't overlap, so I'm just explaining this diagram, please watch carefully. True positive is all true is true, all false is false. So all boys are classified as boys, all girls are classified as girls. Think of like that simple problem. Okay, so there is no overlap. Okay, so if someone girl has done a boy cut hairstyle, you might misclassify her as a boy. If someone boy is growing hair, then you might misclassify as a girl. Okay, so for a problem, just walking up this story. Okay, so here there's no overlap. You can see ROC curve is a straight, full straight line. Okay, but if you see in this case, there is slight overlap. Okay, some true positive have been classified as false negative. Okay, false negative, and some true negative have classified as false positive. Okay, in that case, the AOC is 0.7. Okay, then it is fine. Okay, a certain region. Okay, that is fine. But if you see AOC as 0.5, there is a there is a full overlap. So all the yes or no, apple or pomegranate, girl or boy, it is completely overlapped. You can't even come up with a proper decision. Okay, then AOC will be 0.5. And if AOC is 0, what will happen is all the true positive you classify as, all the yes you classify as a no, all the no you classified as a yes. Okay, it's vice versa. You have invertedly you have classified. In that case, you can see the line goes like this. Okay, so mostly it can be either AOC 1 or else AOC can be maximum, like more than 0.5. So if you get more than 0.7 or 8, then we can consider, okay, our model is performing okayish. Okay, it's not great, then it is just okayish. Okay, fine. So let's come to now we have seen this. Okay, next come to which data set they should use to measure the performance of the machine learning model. Okay, so we have built our model. Now we have found out, okay, we can use these mean square error and mean absolute error and confusion matrix to evaluate the models. But how to evaluate? Okay, there also we have a thumb rule called test data and training data. As I said, let's say I'm teaching you mathematics in classroom. So if I taught you 1 plus 1 is equal to 2 and 2 plus 2 is equal to 4, same old mathematical problem. But in the exam also, if I ask you the same question, what is 1 plus 1 and what is 2 plus 2, if you give an answer 2 or 4, I will not able to evaluate whether you have actually understood the concept of addition or else you have directly memorized it. Okay, you cannot actually evaluate it. Okay, so similarly, if you are training a model, you feed in some data to train the model for the model to understand the pattern and model it. But if you use the same data to test it, and again model will give 100% accuracy, but you will not know whether this model has actually learned the mapping, the learned the function, or else it is just memorized the values. Okay, so that is why we do training data and testing data. We split up the data into training data and testing data. Okay, so training data is used for training the model and testing data is used to evaluate the model. Okay, so all the evaluation is made on this test data. So the evaluation we have seen earlier, all this accuracy, ROC, AOC, being done on the test set. It's been also done on the training set, but it would mostly give us 100% most of the time. If your model is sophisticated, it would correctly predict every time for training data, but for testing data we would do it. Okay, next we will come to cross validation. Okay, and again, based on these things, we can find whether the model is overfit, okay, or underfit. Okay, so what is overfit in the sense? Uh, so what is overfit? I will give a small example, an intuitive example. So let's say you are teaching your kid how to recognize cat and dog. Okay, but let's say in your village you only have brown dogs. Okay, so all you have showed the dog is only the brown dog. You show your baby a brown dog, number of different types of brown dog, and you tell it as a dog. Okay, and you show a cat, and in your village, unluckily, you only have white cat. So you show all the white cat and you tell him this is a cat, and suddenly you come up to the, so that is what the data you have been used to train your kid, all brown dogs and all white cats. Okay, and now you are coming to a new city, all the cats are in brown in color, all the dogs are in white in color. In that case, if you show him a baby, because machine learning model is mostly a baby, it is not an adult, it cannot think on its own, it purely based on the data like a kid. Okay, what you teach, it tries to replicate it. In that case, what will happen is if you show him a white dog and ask him what it is, it would tell a cat, because all it has seen white color in a cat only. Okay, so that is what overfitting is. So training data, your model will be able to perform very good in training data, will not able to generalize or identify for the testing data. So that is what overfitting is. But underfitting is your model itself not able to fit for the data. because you have diverse set of data. Let's say in your village you have dogs of every color. You have green color dog, you have red color dog, you have orange color dog, you have black color dog, you have all colors of dog. And every day you show him a new color or new type of dog to your kid and teach him this is a dog. Then your baby will be confused. Okay, one day dog is in small size and black in color, another days dog is tall and white in color. Then how should I be able to map the function or learn the function? So that is where underfitting, when you have a diverse data, your model will not able to fit it. Okay, your model will not be able to learn from the data. Okay, that is where the underfitting happens. In that case, we go for data augmentation, or else you have a complex model to map the function. Those kind of cases. Okay, those are two things. And why do we need cross validation? Cross validation we use for different purpose. Okay, finally I will give a summary. We are covering a lot of concepts, please bear with me. Okay, so let's say you have different types of models. Now we have, for classification, we have logistic regression, we have k nearest neighbors, and we have support vector machine. Okay, and now you wanted to find the best model for your data. So for your data you need to find the best model. In that case, what you do is, first thing is you take the data. Okay, now we have told you, first thing you have to split your data into training data and testing data. Only then you will be able to evaluate your model based on the testing data, right? Okay, so how you can split them? You can split them 70-30. Okay, it's not 50-50 is not recommended, mostly 70-30 or 80-20. Okay, in that case you can split up and you can train a model and you can come up with some accuracy. Okay, and for logistic regression, for k nearest neighbor, for support vector machine, for everything you split up the data into 70-30 and use the same data to train the model and evaluate the model. Okay, but the question what I'm asking is, how do you know the first 70 or 80% of the data? The data is randomized, but even though this is just one time task, right? One time you are splitting up the data into 70 and you are training your model. So let's say in 70-30, let's say you have 100 dog images for training your model. Okay, or else 50-50, 50 dog images and 50 cat images to train your model. Okay, so in 50 dog images, only 10 are black dogs. Okay, while splitting the data, unluckily or unfortunately, what happens is, if sometime, because it is random, right? What if all the 10 black dogs falls in the testing data? So your baby would not have, like, will not get a chance to see a black dog during the training phase. Okay, so that's the same concept for this thing. If you split up the data one time, 70-30 or 80-20, and you train your model based upon that, your model will give some accuracy, but it is not for every data combined. Okay, in that case what you do is we go for cross validation. In cross validation, what you do is we split up the data into k fold. So that is where the k fold cross validation comes in. So k fold is, the k is the number of folds, the number of splits you make. Okay, so in here we make 4 split. Okay, so the first thing what you do, you consider 1, 2, 3 as training data and 4 as testing data, and you train your model and you find how much correct and how much incorrect. Okay, and second, you use the 1, 2 and 4 as training data and 3 as testing data, and you find how much correct and incorrect. Okay, and you do it for all 4 things. Okay, all 4, like, and third you use 1, 3 and 4 as training and 2 as for testing, and finally you add up all the result. So that for logistic regression it is 16 correct and 8 incorrect, svm 18 correct and 6 only incorrect, for knn 10 correct 12 incorrect. So this cross validation based model evaluation would be more generalized, because it has seen all the data, because you have split up the data 4 pieces and you have fed in all the 4 pieces for different times. Okay, so based on that you can find up a right model. And also here we have done 4-fold cross validation, but it is not limited to it. You can do leave one out. So here, let's say you have 10 data, you leave one out and use 9 for training and 1 for testing, and again for the next iteration you would use the other 9 for training and use this one as training. So totally you would have 10 cycles. For 10 cycles, for the first time, first one is test and 2 to 10 is training. For the second one, 2 is test, 1 and 3 to 9 is training. Like that it would go. And also you can do 10-fold cross validation. You can do split up into 10 blocks and do the okay? So that is where this cross validation comes in. So all these process iterates again and again and again. Okay, the first thing is data collection. Okay, data cleaning, exploratory data analysis. Okay, and data cleaning, feature transformation, filling out missing values, all sort of stuffs. Okay, and build your model. Okay, to evaluate your model based on those accuracy terms, accuracy and mean square error terms, and use cross validation to evaluate or compare different models against each other. Okay, and this process is a iterative process. You do it again and again and again to fine tune your okay. And finally, once you have your well defined model, you can go and deploy them. Okay, deploy them as in a server or in a mobile phone. You can convert the model into a deployable format. You can use Java server, Flask server, or Node.js, whatever it is, to deploy your models. Okay, so things will go like this: data source, data processing, modeling, deployment, and monitoring. Okay, so that is where things go. This is the framework: business understanding, data preparation, data analysis and modeling, validation, and presentation. Fine. And if you see type of data analytics, okay, so we will touch base few things on data analytics. We have 15 minutes left. We will try to cover as much as possible for now. Okay, so here we have descriptive, diagnostic, predictive, and prescriptive. What we try to achieve through machine learning is predictive. Okay, what might happen, okay, or what is going to happen, what will be the number of it. Okay, but also descriptive can explain what happened, and diagnostic can explain why it had happened. It is purely statistical analysis. So these being done on the historical data, the past data. You take the past collected data and you run up some models and you find something out of it. Okay, and predictive, you try to build a model and try to predict what will happen tomorrow or in the next week. Okay, next we have prescriptive. It recommends action based on the prediction. Okay, it's not only predicts it, it would tell if something goes wrong what to do. Okay, if the demand is more, if it is predicts more demand in the coming days, it will tell what to do. Okay, increase the production, you might, what you can do, how you can optimize your system to deliver that need, and it would give us the predictive things. Okay, and again, simple: descriptive, what happening in my business; diagnostic, why it is happening; predictive, what's likely to happen; and prescriptive, what should I do. Okay, so all these things, but it's off topic, but anyway you should know these things. But what we try to do is do the predictive analytics. Okay, so the difference between data analysis and data science is data analysis is more of descriptive and predictive. Okay, I think this is prescriptive. I think this is prescriptive. Okay, and again correlation and all, but data science more about predictive and machine learning, right? So that is where things comes in. And if you see the roles, a business analyst will do business administration and EDA. He just wanted to take care of the business and also to know what is happening using within the company using the data. But a data scientist will do EDA to understand the data, build models, and do some software engineering. Okay. And again, to recap, if someone had not watched it or paid attention, start with the question, collect the data to address the question, do the data manipulation, data wrangling, data manipulation, cleansing, discovery. Okay, and you build a model. Okay, build a model to get some visualization, or else build machine learning to predict something. Okay, that is how things goes. Now let's come to the basic steps. So this basic steps will focus more on the coding aspect. Okay, so what are all the coding aspect for machine learning? So define a problem, prepare data, choose the algorithm, improve result, finalize model. We have this. Okay. So define the problem. First is what is the problem? Okay. And why does the problem need to be solved? A reason for problem. How should I solve the problem? So this would be the question you would be asking while defining a problem. And data preparation. So why do we need to do preparation? Because machine learning algorithm needs numbers, and some algorithms require certain format of data. Okay. The data format has to be like that. Okay, and in order to remove statistical noise and errors from the data, and also to find the complex nonlinear relationship. So this is where data preparation part comes in. Okay, data preparation, data wrangling, cleaning, pre-processing, pretty much same. What are the tasks include? Data cleaning, data transformation. So data cleaning is identify and correct mistakes or remove null values. Feature selection, which feature is correlated. Like feature selection is, okay, let's say you wanted to predict final mark of a student. It internal marks or its attendance percentage or is extracurricular activities might affect the final exam marks. Okay, but whether what dress he is wearing to that particular day or what color of pen he is using or else what hairstyle is put up, will that define the outcome of his marks? No, right? So feature selection is identifying which value has a correlation to the value what we are trying to find the output of. Okay, and data transformation, changing it, feature engineering, okay, finding creating new set of features from the existing features, and dimensional reduction to reduce the dimensions. Okay, and third is choosing the right algorithm. Okay, choosing the right algorithm, we have whole set of algorithm. We will see regression algorithm. We will see why it is used. Okay, regression is used to model relationship between variables. Okay, so it finds error and it tries to optimize the error. Okay, so it's mostly to find a continuous value, so regression, and also it's used for classification as well, but it's mostly about relationship between an dependent and independent variable, right? And we have instance based algorithms. So these instance based algorithms mostly based upon the um, distance. Okay, so k nearest neighbor, support vector machine, so everything is classifies based on the neighboring values. Okay, k nearest neighbor we will see today, it is not purely based on error metrics. It would consider the neighboring data points. Okay, neighboring data points to uh, do the prediction or classification. Okay, and regularization, in order to avoid the overfitting, you penalize certain terms to avoid over to regularization, but that is too much for the initial stage. Okay, decision trees algorithm is tree based method. It is like building a if else, okay, through data. So basically we write if else, right? So similarly, and from the data, the decision tree algorithm, the tree based algorithms will build the if else automatically from the data, right? So tree based method constructs decisions, so yes or no. Okay, so yes or no at the top level and yes or no at the bottom level, yes or no. So at every stages it kind of asks us the yes or no and it gives us what to do, right? And Bayesian learning, naive Bayes, statistical and probabilistic based methods. Okay, we have all these things. And next is clustering algorithms. Based upon the similarities we can do clustering. Okay, uh, and next is association rules, a priori and LCAT algorithms, and artificial neural networks inspired from human brain, has neurons, nodes, and layers, kind of used to map complex functions and complex structures and functions. And next we have deep learning, convolutional neural network. So all these neural network can put up in different architectures. The CNN are very good at extracting features from an image and classifying it. RNN are very good at sequence modeling. LS team are very good at sequence modeling, especially in having long-term context and retention. Autoencoders are used to map out data or else to reduce the noise. Okay, and deep belief networks and both functions kind of similar to neural network. Okay, and next we have dimensionality reduction. Dimensionality reduction is why do we need to reduce the dimension is, see, let's say you wanted to find the prediction. Okay, let's say you wanted to predict something, and let's say you have 100 features. Okay, you have all sort of features. Let's say you wanted to find the final marks for a student. You have his attendance marks, you have his extracurricular activities, you have his internal marks for all things, you have his 10th mark, 12th mark, which area is coming from, his parents educated or not, does it he has a parent or not, is whether he's an hosteler or is a day scholar. So you will have a lot of features which might affect the final exam result. Okay, but you will not know, like, either all of these features are important or else either one of these features are important. So that case you can go for correlation. Okay, and you can find the most dominant feature which affect the end result. And also using dimensional reduction, what you can do is you don't have to neglect all those features. You can what you can do is you can reduce the dimension, like the information what those 10 features or 100 features provide, we can bring down into 3 or 10 features. Okay, so all the information will be packed in within those 10 variables. So that's where dimensional reduction comes in. And ensemble methods, we can stack up multiple models to improve the result. That is simple. Okay, let's say uh, uh, for a certain set of data, logistic regression is working fine. For another set of same data, decision tree is working fine. What you can do is you can club logistic regression and decision tree together, then you can get the cumulative result. Okay, and this is categories. And choosing the right algorithm, we should use cross validation, as we have chosen the algorithm in the does the we have done cross validation, right, for to classify KNN, logistic regression, and decision trees. We can go there. Okay, and why do you want to stop checking algorithms? We will come to stop checking algorithms, but let's see the benefits alone. Stop checking algorithm is trying out multiple algorithms in one shot. Okay, that we will do today. But why do we need to do speed, objective, and result? Okay, we will do that anyway. We will skip these steps and improve the result. Algorithm tuning, okay, hyperparameter tuning, okay, ensemble models. So ensemble models is again use of multiple models combined. And finally, extreme feature engineering, that's what used. And final model deployed on a server or some mobile phones. Okay. And summary, high level steps in machine learning: define the problem, prepare the data, okay, choose the algorithm, improve the result, and finalize the model. So all these things are in the data science life cycle. Okay. Next, let's move on to the data wrangling and exploratory data analysis. Okay. So this data wrangling and exploratory data analysis as a series of slides. I'll just give you a trailer of it, what we are going to see in the next session. Okay. So all these things, understanding data, importing libraries, finding how to connect database, pre-processing, what are all the functions it has to offer, normalization, standardization, histograms, binning, and data mugging, data preparation, feature engineering, exploratory data analysis, ANOVA method, statistical analysis, group by, pandas, correlation map, all sort of stuffs we will see right after the break by 11:30. And we will also see the code. Okay, we will see theory for half an hour, not half an hour, maybe 20 minutes, and we will directly jump onto the notebook to use all these stuffs to put to practice. Once we have learned all these steps, okay, right from data import to data cleaning to EDA to model building to evaluation to deployment, we will be able to execute a project in the afternoon session. Okay. So I think we have 2 minutes left. So any questions and things what we have seen so far, you can drop your question in the chat box. I'll try to answer, or else come up with a question in the next session. Okay, we will try to use all those queries to will try to answer all those things in the next session. Okay. Any queries? See, prescriptive analysis is, as I said, prescriptive is kind of gives you, it also tells you what will happen, and it also tells you what to do. Like you will get a disease at this point of time, and if you get this disease, uh, you should follow these diet practice, or else you should take these tablets. Okay. So that way you can, it also gives you the prediction and also gives you the solution as well. Okay. And cross validation, it's not only for machine learning, it can be used for any technique. It can be used for clustering, it can be used for any modeling technique. Basically, cross validation does is, when we split up the data, it is not just the first half of the data is used for training, or not second half of the data is used for training and testing. Okay. You should feed every part of the data to the model so that it can get a cumulative, like it can understand the data thoroughly, every set of data, and it can give out the average result. Then only then you will be able to do the model. So let's say you build a model based on only the first half of the data, it would perform good. But what if the second half of the data is much more complex, your model not able to. So cross validation is used to split up the data and feed into the model, and it can be used for anything, not only for supervised learning. It can be used for clustering and other sort of stuff and all. And bias and variance, again we will come to bias and variance when we will see the next session. Okay. For this overfitting and underfitting concept, for that we will explain the bias and variance. Okay. And any more queries? And thank you for all the feedbacks. We will continue at the same pace, and we will try to deliver much more informative things in the second session. Okay. I think it's sharp 11. We'll go and have some coffee and get back by 11:30. Okay. Hello, Sridhar sir, are you there? Should we stay online or leave the meeting and join back again?
Ravnesh sir, you may leave and off. You can join at 11:30.
Okay, sir. Fine, sir. Thank you.
Okay, sir. Thank you. Welcome.